The proportion of working adults who miss breakfast on weekdays is estimated to be 40%, in other words, proportion 0.4. Study takes a random sample of 400 working adults. What's the approximate distribution of the sample proportion of workers who miss breakfast? So that's going to be a normal distribution with a mean of 0.4, and the variance is going to be 0.4 times 0.6 divided by 400. So we can calculate that. So 0.4 times 0.6 divided by 400 is 0.0006. So what is the probability that the sample proportion of workers who miss breakfast is greater than 44%? So we're doing the probability that x is greater than 0.44. So that is going to be a normal CDF with a lower of 0.44, an upper infinity. Sigma is going to be the square root of 0.0006, and the mean is 0.4, and that gives me 0.0512. Tom takes a random sample of 400 adults. He obtained his sample by selecting the first 400 workers he met in a busy mall in Perth during lunchtime. Not quite sure how that's a random sample. So discuss briefly two possible sources of bias in his sample. Well, he's at one location, one time, the lunch hour, and he took the first 400. So this statement that it's a random sample is questionable. Amir suggests that a better sampling scheme is to obtain a random sample of 400 voters and contact them by telephone. Outline one source of bias in Amir's sampling scheme. Well, it's restricted straight away because only people with listed phone numbers can actually be in the sampling frame to start with, so listed numbers, and only some will pick up, and therefore there will be a certain amount of self-selection as well, because even some who pick up won't actually answer the questions. So there's a couple of potential sources there. But which method is better? Actually, Amir's is still better because at least there was some sort of randomness in selecting the sample. You'll have got people from multiple locations who had different lunch hours and that sort of thing. So the fact that there's some sort of randomness with Amir makes it better.